Alright, so this video is going to be solving equations that have radicals in them. So the section that you're going to be looking at is O3, Part 1. Okay. The second part of Part 1 is going to have absolute value equations, and I'm just going to do that in a separate video, but they'll both be on the same assignment. So what we need to remember here is that radicals can be undone by squaring. We also need to remember that anything under the radical is grouped together with other things under the radical. So in order to get to anything that's inside, we have to actually get rid of those radicals first. So on this one, since everything is under a square root, like this entire side and this entire side, I can actually just get rid of the radical by squaring both sides. Now notice here it says to solve each equation, and then it says remember to check for extraneous solutions. So what that means is sometimes you may get solutions that aren't actually solutions, and that's because of the nature of taking square roots of variables and the fact that sometimes like a negative number, when you square it, will still come out positive. Like those kind of things make it so sometimes we get solutions that are not accurate when we have radicals involved. So in order to, I guess, deal with that problem, we need to check for extra solutions. So I'll show you how to do that. But first, let's just go ahead and get going on solving this. So in order to solve an equation, I need to get the variable all by itself on one side. So that's the goal. In order to get to these variables, since they're under the radical, I've got to get rid of the radical. So the first step is I'm going to square both sides. So if I square this, those actually cancel each other out, the radical and the squared, and I'm just left with n plus 7 equals negative 1 minus 7n. So in order to get all the n's together on one side, I'm going to add 8n to both sides. I could have also subtracted 1n from both sides. That would work just as well. I'll get the same answer in the end. So this gives me 1n plus 8n, which is 9n. So 9n plus 7 equals negative 1. Why did I add 8n? Silly me. I should have added 7n. I think I was just thinking that 7n plus 1n is 8n, right? So add 7n to both sides, and that will give you 8n. Sorry about that. So 8n plus 7 equals negative 1. So now subtract 7 from both sides, because again, we're trying to get that n alone. So 8n equals negative 8, and then divide both sides by 8. So n equals negative 1. So n equals negative 1 is the solution. But whenever I'm dealing with an equation that has radicals in it, I do need to check for extra solutions. So I'm going to take and plug negative 1 back into the equation, the original, and see if it is actually true. So this would give me the square root of negative 1 plus 7 equals the square root of negative 1 minus 7 times negative 1. So let's just simplify each of those. Negative 1 plus 7 is 6, so this is the square root of 6. On this side, I have negative 1 minus, and then I've got 7 times negative 1. So that would become a minus 7. So this is the same as negative 1 plus 7 as well. So it also equals the square root of 6, which means they do equal each other, and that's a good solution. Okay? So just check your solutions by plugging them back in at the end. So let's try another one. Let's actually do one that's just not quite so similar. So on this one, notice I have a square root on one side and not on the other, right? So I'm going to go ahead and I'm going to square both sides to get rid of the square root, so those will cancel, and then I'm left with 6 squared, which is 36, equals 6m. So now all I need to do is divide both sides by 6, so they'll cancel here, and m is equal to 36 divided by 6, which is 6. So now before I go ahead and say that's the solution, I got to just double check and make sure if I plug it in, it gives me an equation that's actually true, and it does, because this is 6 equals the square root of 36, which means that 6 equals 6. So that checks out, so that is a good solution. Okay, so we're trying to undo the radical. If it's a square root, I undo it by taking or by squaring it. And then you just solve as normal, okay? And then just check your solutions. Let's go ahead and skip ahead. Okay, so on this one, I have a variable over here as well as over here. But still, I want to get rid of the square root first, so I'm going to square both sides. And that gives me 72 minus n equals n squared, right? The square and the square root will cancel one another. Notice here, now in my equation, I have an n squared, and I have an n, and then I have a number. So because there's both an n squared and an n, I can't just solve this like by using square roots or something to get n by itself. This is actually a quadratic, so I'm going to need to solve this by factoring or x factoring. And in order to do that, I first need to get this into standard form with one side equaling 0. So I'm going to go ahead and I'm going to add n to both sides, and I'm going to subtract 72 from both sides just to get everything on one side and the other side equaling 0. So this would give me n squared plus n minus 72 equals 0. So now that it's in standard form, I can solve it using x factoring. So a is 1 and c is negative 72. So if I multiply those together, I get negative 72. B is 1. So I'm looking for two numbers that multiply to negative 72 and add to 1, which is just 8 times 9. Because this number is negative, one of these has to be, and because my result is positive, I know the bigger number will be positive. So this is going to factor to n minus 8 times n plus 9. That's going to equal 0. Remember, I need to divide each of my factors by a, but a is 1, so it won't change anything here. But now I can go ahead and solve this. I know that for this one to equal 0, n would have to be positive 8. For this one to equal 0, n would have to be negative 9. So here's the two solutions that came out of that. Now we need to check them and make sure that they actually pan out. So if I put 8 in there, 72 minus 8 equals 8. 72 minus 8 is equal to 64. And the square root of 64 indeed is 8. So that one checks out. That one's a good one. Now let's try negative 9. If I put negative 9 in there, I'm going to get 72 minus negative 9 under the radical, equaling 9. So 72 minus negative 9 becomes 72 plus 9, which is the square root of 81. And the square root of 81 indeed does equal 9. So that one also checks out. So that one just has two solutions. Okay. Now if one of them would have worked and one of them did not work, then I would have known, or I just wouldn't have thrown out one of the solutions and I would have said just the other one is the solution. Okay. So let's try another one. If you'd like to pause the video and try it on your own first, that would probably be a good idea. And then come back and join and see how you did. I'm going to square both sides here to get rid of my square root. I've got 110 minus k equals k squared. So now I can get this in standard form by putting it all on one side. So that's just moving the k over and moving the 110 over. Remember, anytime you move something to the other side of the equation, it's going to be the opposite sign. And then this is going to equal 0. So now I can use x factoring to get my solutions. So I need two numbers that multiply to negative 110 and add to 1. So it looks like 11 times 10 would work. I would want the 10 to be our negative because our result when we add them should be positive. So 11 and 10 are my factors. So k plus 10, k plus 11, and k minus 10 equals 0. I would divide each of these by a, but a is 1, so it's not going to change anything. And then go ahead and find your solutions. So for k plus 11 to equal 0, k would have to be negative 11. And for k minus 10 to equal 0, k would have to be positive 10. So here's my two solutions, negative 11 and 10, and then I just need to quickly check them to see if they're both good. So let's do negative 11 first. So if I do 110 minus negative 11, I'm going to get plus 11, and then equals negative 11. So 110 plus 11 is 121. And the square root of 121 equals positive 11, but it does not equal negative 11. So that one is not a good solution, so I'll just cross that one out. Next, I'll check 10. 110 minus 10 is the square root of 100. And the square root of 100 indeed does equal 10, so that one checks out, so that one's a good solution. Okay. All right, let's try one that looks just a little different than this, and then we should be good to go on these. That one's similar, that one's similar, similar. Okay, this one looks a little bit different, right? We have a minus 3 equals the square root of 6a minus 26. So because this square root is the only thing on this side, I can get rid of it by squaring this side. But if I square this side, I've got to square this side. And so that means I have to square the entire side. So I have to square a minus 3. So remember, if I have a binomial that's squared, I can't just square a and square 3. I have to actually write this as a minus 3 times a minus 3. And then these will cancel here, and I'll have 6a minus 26. So now I'm going to have to go ahead and multiply this side out. A squared minus 3a minus 3a, and then plus 9 equals 6a minus 26. Now I'm just going to simplify and get everything in standard form. Here I can add these two together because they're like terms. And then it's still equal to 6a minus 26. I need to add 26 to both sides and subtract 6a from both sides to get rid of these. So that side becomes 0. So that leaves me with a squared. Negative 6a minus 6 more a would be negative 12a. And then 9 plus 26 is 35. So there's my quadratic then that I would need to solve using x factoring. And then just make sure you plug them back in. So I'm actually going to skip the very end part there, and I'm going to go on to another one. But you would need to go ahead and x factor that. This one looks a little different in that I have a negative 3 multiplied out front. So in order to deal with that negative 3, I can't just square this side because that negative 3 is not under a square root. I guess I technically could, and I could square that too. But it would be better to make sure your radical is all by itself on one side before you undo the square root. So this is going to give me 9 equals the square root of negative 9 minus 10x. Now I can go ahead and square to get rid of that square root. And that gives me 81 equals negative 9 minus 10x. So now I just need to add 9 to both sides. So 90 equals negative 10x. And then divide both sides by negative 10. So x equals negative 9. Go ahead and plug it back in and see if it works. But I'm pretty sure that one does. But again, you need to check each time and see if they work. Alright, so that's it for this section, and we will continue in another video talking about the absolute value equations that are on the same worksheet. So have a great one.